Welcome back to Networking Explained, Episode 8. Today we're tackling a question that sits behind almost every real-time feature on the modern web. What exactly is a WebSocket? The short answer is right there on screen, a two-way, always open pipe. And by the end of this episode, you'll understand how that simple idea powers chat apps, multiplayer games, and live dashboards without your browser ever having to hit refresh. So to see why WebSockets matter, let's start with the limitation they solve. HTTP is fundamentally one way. The client asks, the server answers, and then the line goes dead. If you want fresh data, your only option is to keep knocking on the door, over and over, dragging new connections and fat headers along each time. It's wasteful, it's slow, and it's never truly instant. But what if that connection just stayed open? And either side could speak up the moment they had something to say? Well, that's a WebSocket. So here's the definition in one breath. A WebSocket is a persistent two-way connection between browser and server, where either side can send data the moment they have something to say. Three things make that powerful. The pipe stays open, so there's no reconnecting. It's full duplex, meaning both ends can talk at once without waiting their turn. And once the initial handshake is done, the overhead per message drops to almost nothing. To make that concrete, let's reach for an analogy. HTTP is like sending letters back and forth. You write one, drop it in the mailbox, then wait for a reply before you can send the next. A WebSocket, on the other hand, is like picking up the phone. The line stays open, and the moment either person has something to say, they just say it. No envelopes, no waiting, and crucially, both sides can talk and listen at the same time. Now let's see that side by side. On the left, HTTP repeats the same little ritual over and over. Request out, response back, request out, response back. Each exchange its own short-lived conversation. On the right, WebSocket does the handshake just once, and from then on, it's a single open line where messages flow in either direction whenever they're ready. Same two computers talking, but a completely different shape to the conversation. So how does that single open line actually get set up? It begins life as a perfectly normal HTTP request. The client sends a GET, but slips in two special headers. Upgrade, WebSocket, and connection. Upgrade, basically asking, hey, can we switch protocols? If the server's on board, it answers with a 101 switching protocols, and from that moment on, the conversation stops being HTTP at all. The same TCP connection is now a live WS pipe, ready for messages to flow both ways. Now let's zoom out and look at the whole lifecycle in 5 clean steps. It opens with that upgrade handshake, becomes established the moment the server replies 101, and then we hit the interesting part, messages flowing freely in both directions, anytime. Underneath, little ping-pong heartbeats quietly check the line is still alive, and when either side is done, a clean close shuts it all down. Open once, talk freely, close cleanly, honestly, that's the entire model. So where does this open pipe actually shine? Anywhere you need information flowing the instant it happens. Chat and messaging is the obvious one, but the same model powers live multiplayer games, trading screens, and real-time dashboards where every tick matters. It's also what's quietly driving your live notifications, the cursors moving around in collaborative editors, and the little dot tracking a delivery on a map. Basically, if the UI updates without you asking, there's a good chance a WebSocket is behind it. Now let's see what this actually looks like from the browser side, because the API is refreshingly small. You create a new WebSocket pointing at a www URL. That's just WebSocket over TLS, the encrypted version. And then you wire up a few event handlers. On open fires once the pipe is ready, on message runs every time the server pushes something your way, and on close lets you reconnect if the line drops. That's really it. No polling loops, no clever timers, just a conversation. So before we go further, let's put WebSockets next to the alternatives because they didn't appear in a vacuum. Plain polling just reasks on a timer. Simple but wasteful and laggy. Long polling holds the request open until something happens. Better, but still kind of one way. SSE gives you a clean server-to-client stream, which is great when only the server has news to share. And WebSocket is the one open, two-way pipe, full duplex and low overhead. So the rule of thumb is easy. Server-to-client only, reach for SSE, need both directions talking freely. That's WebSocket. Now there's a catch with all this power. WebSockets are stateful. Unlike a quick HTTP request that's done in a blink, a WebSocket stays open, meaning the server is holding a live connection for every single user, and that adds up fast. So at scale, you need a few tricks, sticky sessions or shared states, so a user's messages reach the right server, pub, a sublayer like Redis to fan messages out across your fleet, and heartbeats with reconnect logic to catch dead connections and recover gracefully. Now, scaling isn't the only thing to worry about. Security matters just as much. So a few non-negotiables on the do side. Always use WSS, so your traffic is encrypted. Authenticate the user before or during the upgrade handshake. Check the origin header to make sure the request is coming from a domain you trust, and treat every incoming message as untrusted input. On the watch-out side, the big one is cross-site WebSocket hijacking, often shortened to CSWSH. That's where a malicious site opens a socket using a victim's cookies. Beyond that, don't blindly trust message contents. Add rate limits to prevent flooding, and be very careful about which connection you're sending data to, so private messages don't end up in the wrong pipe. All right, with security covered, let's clear up a few myths that come up a lot. First, WebSockets don't replace HTTP. They actually start as an HTTP request and then upgrade, so most real apps happily use both side by side. Second, they're not always the best tool for real time. If data only flows from server to client, server-sent events are simpler and lighter. And third, don't assume the pipe stays open forever. Networks drop, so you'll need to build in reconnects and heartbeats yourself. So that naturally raises the question, when should you actually reach for WebSockets? They're a great fit whenever you need two-way, low-latency messaging. Think chat apps, multiplayer games, live collaboration tools, or anything where both sides need to speak up whenever they want. But if you're just doing simple request response, plain HTTP is fine. If only the server needs to push, SSE is lighter. And for rare updates or mostly static sites, an open pipe is just overkill. Now, once you decide WebSockets are the right tool, you'll quickly bump into a whole ecosystem built around them. On the library side, Socket.io is the classic in JavaScript land with handy fallbacks. WS is the minimal node server, and Phoenix Channels powers Elixir's real-time stack. For net folks, there's Signal, and if you'd rather not run your own infrastructure, managed services like Pusher and Ably handle it for you. And for quick debugging, keep WSCAT in your back pocket. It's a tiny CLI that lets you open a connection and poke at it by hand. So let's pull the big ideas back together. A WebSocket is one open, two-way pipe that starts life as an HTTP request and then upgrades to WS, after which either side can send a message whenever it wants. It's a fantastic fit for chat, games, and live data, but not every app needs it. And because the connection is stateful, scaling it out takes a little more planning than your usual stateless HTTP service. So if you do decide to build with WebSockets, here are the habits that pay off. On the do side, reconnect with a backoff when the link drops. Send little ping-pong heartbeats so you notice dead connections early. Keep your messages small and well-structured, and always authenticate the socket. Don't trust it just because it's open. And on the avoid side, don't reach for WebSockets when a plain HTTP request would do. Don't assume the pipe stays up forever. Don't stuff huge payloads into a single frame, and never skip auth or origin checks. Now, if you want to go deeper from here, there are two natural paths. The Networking Explained series covers the neighbors of WebSockets, HTTP and HTTPS, TLS, reverse proxies, load balancers, all the pieces that sit around your live pipe. And here's the thing. An always open connection is also an always open door, so the server behind it has to be hardened. If that's your next concern, check out SSH Hardening Mastery over at dargslan.com courses. Before we wrap up, I've got a quick question for you. What's the last app you built with WebSockets? Maybe a chat, a multiplayer game, a live dashboard, or are you still reaching for polling out of habit? Drop it in the comments. I genuinely love seeing what people are building with that two-way pipe. And that's a wrap on WebSockets. If this episode made the whole two-way pipe idea finally click, hit subscribe and stick around for the rest of the Networking Explained series. We've still got plenty of protocols to unpack. You can also find more deep dives over at dargslan.com. Thanks for watching, and I'll catch you in the next one.